Alright, so let's solve this interesting LeetCode problem today, which is Dota2 Senate. It says, in the world of Dota2, there are two parties, the Radiant and the Die. The Dota2 Senate consists of senators coming from two parties. Now the Senate wants to decide on a change in the Dota2 game. The voting for this change is a round-based procedure. In each round, each senator can exercise one of the two rights. One, which is ban one senator's rights. A senator can make another senator lose all his rights in this and all the following rounds. And the second right is announce a victory. If the senator found the senators who still have rights to vote are all from the same party, he can announce the victory and decide on the change in the game. Now, given a string Senate representing each senator's party belonging, the character R and D represents the Radiant party and the Die party. If there are n senators, the size of the given string will be n. The round-based procedure starts from the first senator to the last senator in the given order. This procedure will last until the end of the voting. All senators who have lost their rights will be skipped during the procedure. Suppose every senator is smart enough and will play the best strategy for his own party. Predict which party will finally announce the victory and change the Dota2 game. The output should be Radiant or Die. Okay, so as you can see, it's quite a long question, so you can just read through it again. But I'll explain the idea to you. So if you look at example 1, we have R and D. One senator for R and one senator for D. In the first round, Senator R simply bans Senator D, which makes him to win. Let's go over to our whiteboard and understand it better. Alright, so I have our whiteboard here, and I've brought out two examples we use to understand how we solve this problem. So the idea behind this is quite simple. Anytime we encounter a particular senator, we want to greedily ban the other senator. Okay. For instance, in this example 1 here, we encounter R. You know that we have one senator for R and one senator for D. So all the senators are like in a queue, taking turns. So in this R turn now, this first senator R, in his turn, is going to greedily ban D. So let's say we have another variable called banned D. We just call it BD, which will be 0. Now in his turn, after banning D, D will be increased to 1. And now in the next iteration, this D is banned, so R is the only remaining senator, and so he can be announced the winner. Okay, let's explain better with this one. We have a queue like this. We have D, R, and R. We initialize our number of supporters, our number of senators for R to be 2, and for D to be 3. R is 3 and D is 2. Now we'll also initialize another variable to keep track of how many of the opponent's senator we have banned. So we'll call it BD is equal to 0 and BD R is equal to 0 2. Now is this guy's turn. What he's going to do is to greedily ban one of R. So now we're going to increment our BD plus 1. Sorry, our BR plus 1. And push this guy to the end because he's not yet out. So we have D here again. Now D comes again. We're going to still ban another R, incrementing BR to 1 again. And also push this guy to the end. Now when we come over here, we find out that our band R is equal to 2. So this guy has no right to make any decision because he's banned. So we remove him and move over to the next iteration. Also here, the -1 after that. Now also here, our band R is also equal to 1. So this guy can't still make any decision. So we also remove him and decrement our band R. Now we are finally back to 0 with our band R. Now when we come to this R again, this guy can vote. So he's going to greatly ban one of the D. So we increment this one to 1 and push this guy back to the end of the queue. Now it's this guy's turn again. But as you can see, our band D is equal to 1. So this guy cannot make any move. So he simply leaves. -1. Now it's this guy's turn again. He's going to annoyingly ban R and try to ban his man. So we'll come here, increment our R again to 1 and go over to the end and wait for R. Now R comes again now. See that, oops, it has been banned and annoyingly leaves the game or anything. And D remains the last man standing, so is the winner. Now let's implement this in code. Alright, so let's implement the solution. The first thing we'll do is to count how many senators are for R and how many senators are for D. So you can do that any way you want, but this is just how I'm going to do my own. R and I'll just copy and paste for D too. D and D. Yes, so we're also going to convert this our Senate string to a queue as we saw in the whiteboard. So we'll do deck. I'm using the deck library in Python. Then we'll initialize 2 variables as we said, which will keep track of how many of other senators we have banned. So to be banned D band R 0 0 by default. Now I'm going to iterate through this queue while we either have R or D, which means while we still have some senators for R to vote and some senators for D to vote. So you can do while R is greater than 0 and D is greater than 0. First things first, check if the senator at the top has been banned already and removing from the queue. So we'll do that by y is greater than 0. We'll now do how, meaning one senator has left the chat, and put it that way. And we'll also do to reduce the number. Yeah, so we'll also pop. We'll remove it from the queue. Wait, we don't need this. We'll do the same thing for D. Why I say we don't need that line of code was because I'm going to decrement it when the senator makes the decision of banning the other one already. Let me show you what I mean. So finally here, any senator who is at the top of the queue is valid to make a decision. So we can get the senator first. Now, I'm going to check if we are greatly banning D now. So we are going to decrement D here already instead of decrementing it in our while loop. So we are going to add 1 to our band D. Yes, but if that is not the case, we are banning R. So R is equal to 1 and ban R is equal to 1. Finally, this senator goes to the end of the queue because it's still valid. So you can do senate dot. Now, at the end of the loop, R must be greater than D or vice versa. So if R is greater than D, you know that radiant 1, so we can just return radiant, but else return die. Yes, so that's it for the solution, and let's run it. Yeah, oh, sorry, it's supposed to be Senate. Do we still have any error? Don't think so. Okay. Okay, yes, so that's it for the solution, and I think the time complexity of this remains big O of n. That's it. See you guys on the next one.